previously, Professor Stefan already mentioned that they did a lot of tests, a stress test on the Lisp southbound. So what I did in this work is I implemented the whole Lisp a subsystem, which consists of Lisp northbound, southbound, and the thing. So I want to give some updates on this work. And so yeah, I think I would like to just give a brief introduction to this Lisp. I assume that not many guys are aware of this Lisp. And so you can consider this Lisp as a type of a tunneling protocol, like L3 tunneling protocol, like GRE or GTP, and so on. So the idea of Lisp is there are two types. So typically, IP address is typically served as two rules. The first rule is identifying a certain host, right, as ID purpose. The second rule of IP is for locator. So based on the IP, the router can find the root and it can locate a certain packet and so on. So the main problem of the current internet is since IP serves as two purpose, but we just bind that two rules into one IP address. So if your machine, for example, move from one location to another, then you have to change your IP, right? Otherwise, it cannot be located. I mean, it cannot be routed in a certain direction. So that is the main a problem that exists like network. So the Lisp group, they try to resolve this issue. So so I can talk a little bit later about this in depth on Lisp, but here I like the OpenFlow. The Lisp guys, they try to want to make a minimal deployment impact, because for OpenFlow we have to change the whole the network infrastructure. We have, in order to deploy the SD network. But here Lisp, they want to just do not want to change the core. They just want to change the edge router with the Lisp capable router and the minimal changes to the edge device and so on. So this there is a Lisp IETF working group that are driven this standardization. So the idea of one type of IP is served as at the endpoint identifier. We call that EID. So we typically assign this EID to a certain host. And the second role of IP is for routing, right? Routing locator. So this type of IP address is typically assigned to Lisp router, which is nearby the host. And in order to manage the whole thing, there is a mapping system we call EID to RL mapping. And the control plane of Lisp is typically in charge of managing these two EID RL mappings and so on. So there are several use cases of this Lisp, and actually Cisco initiated this protocol, but it is open a network protocol, and I can try to standardize it. So in Lisp we have two one is control plane, another one is data plane. So Lisp router, you can consider this Lisp router as a data plane, and there is a Lisp mapping system which map EID RL. You can consider this as a control plane. So it's very similar like a tunneling protocol. So we can encap, decap, and the whole thing, and the IETF RFC 6830 or some others. It's standardized whole thing. So I just want to briefly mention some mechanism how it can work. So assume that we have two Lisp sites, and for example, in each Lisp site we have several Lisp router, and depending on the role of the router, we can classify the router as two types. One is ITR, another one is ETR. ITR is an ingress tunnel router that goes to the packets actually by using the locator addresses. So here, and we have another router called egress, so it's supposed to decapsulate the packets. So in data plane, so I'm going to show some animations how this data plane will work. So assume that there is some request from Lisp site 1 to Lisp site 2, and the packet, its IP has IPv6 address, and it's initiated by the host. And if it goes through the router, then it tries to encapsulate this IPv6 address with the packets into IPv4 address, as you see. And then it's gonna go and go to the ETR, and it's gonna be the decapsulator. So in that case, even the host only support IPv6, they still can forward it to the destination through IPv4. So this is the main concept. And so yeah, you can see it's quite straightforward. It's just like a tunneling protocol. And we have control like a plane, and there are two entities. One is a map server, and the other one is a map resolver. So this has been like shown by the previous speaker. So map server does nothing but just the register of like a mapping record of EID and dialog. And the map resolver is supposed to resolving this like a mapping request. So here and like this. Okay, so this is some detailed like concept of two like entities. Okay, so I'm just gonna talk a little bit about this control plane. So there are several types of control messages being defined to like manage these mappings between router and the control plane. So once this router has been up, then we're gonna send this mapping register message to the controller. Here we call that mapping system as well. And then this, several like router just register like this. And then the mapping has been registered, then maybe some router want to query the mapping information, then you can send like a map resolver. Map request message like this, and so on. So we have several different types of control messages that been sending between the control plane, data plane. So and so on. So this is the map request process. So once the map register, the message has been sent to the control plane, and if some router want to query their one, and depending on whether the proxy bit has been set to 1 or 0, the controller can immediately send back to the message, or it can delegate such request to the corresponding router. So this is quite straightforward as well. So I don't want to go in deep on this again. Itself, because you can try to read this RFC document. I would like to spend some time to talk about this subsystem. So we implemented and deployed this southbound and northbound into the ONOS. So the overall architecture is like this. So by far the control plane part has been done, and we're still trying to do. So how long? Okay, thank you. So management plan has not been done because so it's based on the conf, and since different like a Lisp router has different like interfaces, so we somehow need to handle this part as well. But so what we did so far is we try to focus on this like standardizing this control plane. So this is an architecture, and we try to follow the ONOS architecture. Like we have this protocol layer, we have this provider layer, we have this. The rule of this Lisp outbound is like you try to so it's generate Lisp events that listeners like subscribe to, and also store like the mapping information of router ID and reference of Lisp router objects. So it tracks all the like Lisp router status and so on. It also establishes and manages and the communication channel for each router object. So unlike the OpenFlow, this Lisp uses UDP, and the OpenFlow uses TCP to connect control plane and data plane. So this part is slightly different, and the visuals are pretty similar. And also we have we did a lot of work on like serializing this control messages. So there are many like control message types. So I just enumerated some of them, and so OpenFlow, in OpenFlow we have OpenFlow J. So that OpenFlow J is sort of like a Java library which is in charge of serializing and deserializing OpenFlow and control message. But in Lisp we don't have such a thing, as far as I know. So we spend a lot of time to implement the whole like serializing and deserializing libraries for Lisp. And so the software that's been committed to ONOS, so you can just download it to see. And also Lisp has several types of address, actually, not only one address. So we also spend some time to try to serialize and deserialize this address. So we call this address as a Lisp canonical address format, we just call alcaf. And it also been standardized by TF-Tract. So we can go in to look. And we're using the NetT 4.1, the latest version of NetT, to deal with the channel management. So also OpenFlow also use the similar like NetT. I think now ONOS inside ONOS it uses NetT 4.1 to manage OpenFlow like channels as well. And we use native ePOL like a non-blocking I/O in Linux OS to leverage the further improve the performances. And this is the several like the requests and the register means how this mentioned can be handled by channel and the mapping system handler and so on. This is a general like a channel pipeline what we designed. And I don't want to go in deep because we are running on time. So this is a mapping abstraction. So somehow in order to make this northbound for this, we actually abstracted some parts. So there are several like a field can be used for common by some other mapping system as well, not only Lisp. So we extracted that like this. So there's the mapping key and the mapping address, mapping action, and then we also try to abstract the usual part like priority, weight, and log AFI, the logger, and so on. So I try to refer some other mapping system to handle abstract the commonality. The common part. So this is a Lisp measurement plane. So we are trying to implement this part, and by far, as far as I know, Lisp only OR is OR only support Lisp like measurement interfaces. Among open sources. So we try to we try to manage this OR using ONOS through this measurement plane. So this work is work in progress currently. And this is the code contribution, the code quality, what we did so far. So if you take a look at this, we try to make this unit test code coverage over like 70%. And we tried a lot, and the drivers and the protocol layer have been well, but some other part we still get under 70%. So we are working on that and to make unit tests cover more like logics and so on. So duplication is like this. So this information like extracted from Sonar Cube, what ONOS project uses, and so on. So this is upstream. So in each release we added the features like this. And now in key feature, so for the details we can just go to this wiki site and to refer to. And the performance test has been done by UPMC Lib 6. So so you can drop by the demo booth of the Lib 6 group and to see the details. And also I would like to give special thanks to the UPMC Lib 6 group. Actually, they did a really good job on assessing all the performance and the things. So thank you for listening. And if you have any question, please feel free to ask.
Consistency, you cited that you implemented for the distributed ONOS, right?
Good question. So actually we use it the distributed store. Actually we use the consistent map, but the things like the idea of Lisp is like Lisp has a different concept of distribute this mapping information. So it follows the same architecture like a DNS. So DNS has a hierarchical way, right? So Lisp also follows the same thing, but in ONOS, ONOS just uses a flex structure to distribute all the information. So that part is quite different. So so we didn't put that part. So we try to make it. We try to use the distributed store, but actually the protocol itself is quite different compared to the standardized one. So that part we are considering how to improve maybe later on. Maybe we can do some hybrid approach. So maybe we can grab some good part from ONOS, like we still can leverage as flag structure. At the same time, we also can maybe use the original Lisp like a distributed, the concept like DNS. So there's but the main thing is like Lisp group didn't standardize for example, the mastership things. If one, for example, Lisp controller just died, then we cannot pick or some other things. And so maybe there's some space that we can further improve that part, and we can maybe write some draft to the IETF and to standardize their part as well.
Okay.
Anything else? Yeah, thank you for your attention. Yeah.